Alright, it is Thursday the 4th of August 2016. We are going to start on the restoration of this here 9400 Wilton Vice. Came out of high school. It is fairly abused, as you can tell. Got it off Craigslist. It's got some issues in addition to being coated in paint. It's got some cracks here in the casting on the bottom, and generally beat up, as you could tell. So we're gonna clean this thing up and put it back in service, and maybe even braze those casting cracks and get her back to being structurally really sound. So anyway, here we go.
Okay, we are moving further on with the disassembly of the vise, and of course with disassembly you learn a few things in the process. Most importantly, on the keyway here, I found the date code here on the bottom stamped 6/30/65, which I believe is the manufacturing date. Occasionally they would put the guarantee date. These vices had either a 5 or a 3-year warranty, but I think this is actually the manufacturing date. So that's good news, knowing that this is about 51 years old. Unfortunately, I also found a couple issues right here on the movable jaws. One of the bolts, the securing bolts, had fractured off a long time ago, and this was just kind of setting in the jaws, wedged into the jaws. So I'm going to have to drill that and get an easy out, and hopefully I can extract that without too much ado. More tragic is over here on the body of the vise. I did not see this when I was purchasing the vise, but as you can see here, a large chunk of the casting fractured at some point in its life. Has been painted over, so this happened a long time ago. But I doubt I'm going to do anything with this. I'll probably leave it just like it is, so I don't further weaken it. But that's disappointing, and I should have seen that. Also, of course, there's the cracks in the casting over here by the shoulder, and if you look inside the tunnel here, there's also a pretty good sized crack that runs down the center of it. So lots of issues. This vise has taken some serious abuse in its lifetime.
Continue on. Got to take this bad boy off right here on the back, and if you can see, there's I did a little bit of wire wheel, and there's a pin that's got to be driven out to release the nut, and then also this back piece that forms the bullet. So we'll see if we can get those off. We got the nut out of the body, and the flange that goes on the hub that goes on the back that keeps it in a stationary position while you're cranking down the handle. It was a little tougher than I expected. These pins, I don't know if you can see that, there's serrations on the pins themselves. And my phone is not, there we go. You can see those serrations. Those didn't seem to be too much of a problem on the first one as I pushed it out into the center. But the second one was much more of a challenge, and you can see I've got a misshapen hole here because I had to drill it out. As you can see here, that's the result of me drilling out, and it's because here on the nut you can see this side goes all the way through and that pin locks in, and this side never actually went all the way through. So from a manufacturing standpoint, they never actually put this pin all the way through. It just went into the hub, and so there was no real way to knock it out because, well, it only went in so far. So anyway, that may be something I'm missing, but for the most part, my challenge now is to do some machinist work to repair some of the damage that I just did taking this thing apart. But then again, I got a whole bunch of stuff to repair here. So anyway, we'll see. More to come. Back to the Wilton Vice, and we are cooking the parts. Got ourselves a inductive cooktop that I picked up at Goodwill for a couple bucks, and just a canning pot. It's nice and hot. So let's see, temperature wise, we are 150 degrees. So that should more than cook the oil and grease and paint off. I'm using a mixture of, let's see, Simple Green, which I've used several times. It's kind of nasty, but it does the job. And then there's a little fountain pump that's moving the fluid around. So we'll let that cook for a couple hours, and we'll see how they come out. The next morning, and here's a good example of what Simple Green heated up to about 190 degrees, and letting this stuff sit in it. It peels off layers and layers of paint beautifully, and grease and grime and muck. So we will remove this, and then I'll be able to get a better look at some of the cracks on the casting on this thing. Okay, making progress on the vise. Got a stress relief hole at the end of the crack on that side, and also 3/3 seconds here in the corner that goes inside, and thankfully will not interfere with the operation of the vise. Same thing over here. This was a little tougher to chase that crack, but I think I did pretty well. It's right in on the keyway on the inside there. And again, it's not going to interact with the action of the vise. So I think what I'll be doing here is grooving out these cracks on the outside, and laying in some, my folks over in C&K turned me on to this. It's actually stick rod, and I'll knock the flux off of it, and I'll use that with my DC TIG welder. And we'll give this a try. It, as you can read here, says minimum preheat temperature for the rod to melt at 350 degrees. I'm going to try and get this thing up to closer to 500 using my powder coating oven over there. So we'll get her up to temperature. First I'm going to groove it lightly, and then we'll get her up to temperature, have everything set up, and then I'll drop it onto that welding table with a welding blanket and try and get these welds put in fairly quickly, and then it goes back in the oven for a very slow cool down, and we'll see how that works. Okay, making progress. Got the relief holes drilled and the grooves cut a bit shallow, as you can see. That's all I'm going at this point. And there's one on the other side, of course. And now we're going to clean this thing off, and we're going to start the preheat process in the oven. All right, it's been about 30 minutes, and the temperature on the oven is 500 degrees. And we are going to check to see what our part heat is at this point. 383. So we are definitely getting there. I figure another 30 minutes and we should be at temp. Okay, here's how the welds turned out after grinding them down. You know, not bad for my first cast iron TIG welding, but you can see porosity is definitely an issue. I mean, it definitely added strength over just the plain old crack, but it's not as strong as I would have liked. I guess I could have done another pass, but all in all, they turned out pretty well. You know, she's never gonna have the strength the original casting had, so can't be wailing on this thing too much. But all in all, I think they turned out okay. The real tragedy was that I had a couple of really bad spots in the anvil portion of the vise, and I tried to, you know, fill in a couple of those holes, and of course this area was just had lots of impurities hammered in over 50 years, and when I started to weld it, I mean, it just blew out hard. And so this is a fail on my part, but I am going to put it on the mill and go ahead and just run a mill over it and then square up these edges, you know, make it as nice as it could be, and then we'll go from there. Okay, got the vise mounted on the mill. Just for the hell of it, I ran an indicator along this edge, got within just a couple thousandths of an inch. Not that that matters too much, since this casting is, you know, it doesn't have to be square to the jaws on this little anvil piece, but you never know. I may want to run this edge right here, clean it up, and of course on the other side, if I really was ambitious, I would put a groove in here and replace this maybe with either cast or even a piece of steel, but that requires welding, and I know this whole area is really dirty and would most likely be so porous I would struggle to get that that piece put in. So I think I'm not going to weaken it any further. I'm going to leave it as is. So anyway, here we go on flattening the anvil section a bit. All right, there's the results of milling the anvil portion of the body. As you can see, it turned out nice and flat, and I got a little bit on the sides as well. But obviously some serious porous sections there where I tried to repair the pits. I actually made them worse. I'm likely going to fill those with some JB Weld, so epoxy, just to, you know, level it out. It's not going to be used much as an anvil. I'm not a big fan of using the anvil portion of a vise for an anvil. It's just a bad practice. But anyway, it'll give it a cleaner look, and I may actually hit a couple of these spots too, just to fill those in, and we'll go from there. Okay, we are about to extract that broken bolt out of the vise jaw, the movable jaw. I've soaked it down with some WD-40 for a number of hours. I'm going to get a center punch, hopefully hit the center. I'll peck it out with the center drill. Then I'm going to start with a number 1 easy out. So I'll drill that out. If that doesn't work, I'll go to the number 2. And if that doesn't work, I'll resort to number 3, and hopefully that takes care of the business. And if I'm lucky, I won't have to use any heat or any of those other techniques to try to break the bond. Hopefully it'll come out easily. Here we go. Well, I got lucky with the first try. The number 1 is doing the trick. As you can see, that broken bolt is coming right out, which is great. And I got relatively centered on it, so there we go. Broken bolt removed. Okay, we continue on with the lathe repair. The movable jaws were missing the pin, the indexing pin, so I'm going to make a new one. Should be pretty easy to cut off from here. It does have a bit of knurling on it, which I will recreate. Very light knurling, so I'm going to do just ever so light a job with that bad boy, and that should be good enough, and I'll cut it off. Alright, there's the hand-hammered copper dust cap from scrap. I think it'll look nice with black. when I finally paint this bad boy. So the coppered dust cap is now in place. Used to be cleaned up just a little bit, but I think that looks pretty good. I've also, with the aid of a long drill bit, I was able to go all the way through to the nut on the inside, and then put 2 pins on either side, and I've confirmed that everything works as it should. Obviously, from drilling out the old pin, I've got some gap there that I need to address. So I'll do that with some epoxy, some JB Weld, and then that stuff will handle about 500 degrees. So I should be able to put this in the powder coating oven and give it a nice coat of black. But I've put some oil on it, so I'm going to heat it up again with the other parts here to get the cast iron to give up some of the goo and muck that is going to interact with the powder coating paint, and that should make a better job. And then lastly, I'm going to get the TIG welder out and take care of welding up some of these gashes that were put in here, I guess from an errant hacksaw. Anyway, it's amazing what a high school shop will do to a vise, but I think I'm getting this one back to working order. More to come. All right, there's the welded handles. Those cut marks are removed. My TIG welder did the first part on the actual handle, and then I ran out of gas, which has been a problem with this Eastwood TIG welder. I think it leaks some gas, so I'm gonna have to dig into it and find out where the leak is, because it's getting expensive. All right, there's the hand hammered copper dust cap after some polishing. I think it turned out pretty well. I kind of like the rough facets from the hand hammering, so I think that'll work pretty well. All right, got everything cleaned up and put back together just to make sure it all fits. Before I go into paint, you can see the brass cap on the back. The dust cap is turned out nice. Kind of a hand hammered finish, but very shiny. And I flipped the jaws upside down, even though they've got a bit of a taper to them. I think that'll look much better than the abused other end. And the handle polished up kind of nice, but I left the character of the abuse of 50 years. So Mary, we'll see how she looks in black. Okay, it's time for some outgassing. So I'm preparing for powder coating, and I have put all the cast iron parts that are going to get powder coated back in the oven at the 440 degrees. It's been in there for almost an hour and a half, still smoking, as you can see. Well, yep, still some smoke. I've got the parts tilted so that any oil or grease or grime is dripping out. Right now they are at, what is that, 160. This one is at 160. That seems odd to me. Oh, I'm in Celsius. Go figure. 350. This one's 306, so I'm going to let it cook for a while longer until it stops smoking. And then we'll let those parts cool. I'll sandblast them one final time to give it a consistent finish, as well as remove any of the grease and grime that came out of the pores of the cast iron. And then we will mask it and do some powder coating, and it'll go back in the oven at 400 degrees for the paint cook. All right, we are over 2 hours into the heating process. We're gonna take a look. See, temperature-wise, we are 350 degrees here, and 340 some odd degrees here. Looks like all the smoking has stopped, so we're going to start the cool down process, and then we will do some sandblasting. Right, the vise has been powder coated and is cooking in the oven 400 degrees. Coming up on 30 minutes of cook time. I suspect I'm going to have to go further. It needs to be roughly 400 degrees, and we'll check it right now. So there's the powder coated version, and we're at 272 on that one and 300 on that one. Okay, so fresh out of the oven. Powder coating is flowed 45 minutes at 400 degrees. Looks pretty good. The black, I think, is appropriate for a vise that has taken this level of abuse. I will probably stick it back on the mill and just scrape off the top layer of powder coating, maybe, I don't know. And then here's the movable jaws, also powder coated, looking pretty good. The polished screw, it's ready to go after everything cools down and is greased up. And then last but not least, the dust cap, which was both polished and now has a coat of clear coat on it so that it won't tarnish. So anyway, we'll put this thing back together tomorrow. Well, the Wilton Vice is done officially. I think it turned out pretty well considering. I had a lot of work to do on this thing. I definitely overpaid for the vise, considering the condition. It required, let's go through what it required. It had a broken fastener on the jaws. It was missing a centering pin, so I had to extract that, make a new register pin. It had cracks in the casting on the corners down here, and also on the side here. You can just barely see where the weld occurred. It was missing the dust cap on the back, and it generally was beat up. So all in all, it was a fun project. I learned a lot about welding cast iron, but all in all, I think it turned out pretty well. And when I tally up my total cost, $85 for the vise, plus another $40 for the nickel rods, which I still have plenty of now. I think I came out okay. So it was a great learning opportunity, and I think it turned out pretty well. And I like the polished copper dust cap with the black. I think that looks pretty good. If I was really ambitious, I would maybe hit the lettering here on both sides with some red paint. But you know what? This is a working vise, and it's going to get abused a bit, so I'm going to leave it just like it is.